What's up, pretty people? I am Bins, and welcome back to the Shapez BEASTMAM series. We are still in the chapter Concepts, where in this second video I want to talk about code values. What are code values? What's their purpose? Why do you need them? Etc. I want to talk about this subject because, firstly, if you want to start experimenting with these types of intricate wiring setups yourself, then the principle of coded values can be anything from interesting to absolutely necessary. And the second reason I want to talk about this is because in this machine, I exploited the mechanic more than I ever have with any other factory I've built. So, without further ado, Chapter 3, Subchapter B, Code Values. First things first, what are coded values or code values? Well, it's an umbrella term I give to any kind of shape or color signal that you generate on the wiring layer that isn't needed anywhere in the target shape nor directly required to build components of the target shape. Instead, these codes are intermediary values, let's call them, that contain information you might need elsewhere in the machine, typically to trigger a certain kind of behavior elsewhere. So, one part of the machine generates these codes, then you transfer them through a wire, and another part of the machine can understand this code in order to do one thing or another. If we look at these three displays near the hub, for example, you can already see three of those codes in use. The leftmost shape is a shape that contains information the machine can read, so it knows when, where, and how smelting needs to occur in order to create the target shape. The middle display tells us more about the stability of the layers contained within the target shape, and the third shape display is an indication of which quadrants are contained in the target shape and which aren't. Okay, but these are just three examples. Now, the most fundamental thing to realize is that these code shapes or code values are part of a system that you must come up with yourself. There isn't a predetermined set of rules or anything. You must come up with a system that you can use in your machine. It's a creative process. These values need to align with a given set of data that you know the identity of. And then you come up with a system of codes that somehow contains that information. And then you also need a mechanism that generates these codes on one end of the machine and another mechanism on the other that is capable of interpreting that value and act accordingly. But the bottom line is there are no pre-established rules. You are the artist. You make up the rules. All right? So let's look at an example. Let's say that I would like a module that determines the height of a shape. And then based on the outcome, the signal is sent one of four ways. Okay, we can imagine that the four outputs are all connected to different modules that are specialized to deal with the shape of a given height or something, right? So, how could we go about it? Do you happen to know a set of four values that we could use? Well, I feel the answer is too evident. There are four base shapes in this game, so those make a pretty solid choice, okay? Then, let's say that if the shape has one layer, we decide that that can correspond to a circle code. 2 layers corresponds to a rectangle, 3 layers to a star, and 4 layers to a windmill. Alright? Now again, we are free to choose these values as we please. There are no rules. However, the best values to choose are the ones that fit a system that makes sense in your head. And in my head, for example, the sequence of circle, rectangle, star, windmill, I find that easy to remember because that's the order in which you get acquainted with the shapes when you start playing from level 1. So that's the order we'll go with here. So if a shape has one layer and we unstack it, then that one layer signal will come out the first unstacker module. So with a transistor, we convert the output to a circle signal. Something like this. If the shape has 2 layers, then we are going to attach a rectangle value to it. 3 layers is a star, and 4 layers finally is a windmill. So let's do that. Like so. So if we put a shape with 2 layers here, for example, like this, we will trigger the second output. A shape with 3 layers will also trigger the third output, the star output, and finally a shape with 4 layers that will also activate the windmill. Now, another pretty fundamental principle of these types of code systems is that they only make sense in contexts where you have a set of mutually exclusive scenarios. In this case, we are trying to determine shape height, okay? And a shape has either 1 layer or 2 or 3 or 4, but it cannot have both 2 and 3 layers at the same time, okay? The height of a shape is not ambiguous. There is only one answer to the question, how many layers does this shape have? And it's quite essential to keep this in mind. These kinds of code shapes that we are going to talk about in this video, they only make sense in situations that mutually exclude each other, all right? And with that taken into account, we can see, for example, that if we take a shape with 4 layers, like we have now, then all of the 4 displays will light up. And we don't really want that. We want only one signal to come from this module that is either a circle or a square or a star or a windmill. So let me tweak this module a bit so that it fits that purpose. There we go. Now, a benefit of this principle is the fact that we can combine all of the output lines, like you see I have done here. Since only one value can ever apply per scenario, in other words, there is only ever one answer to the question we're asking. In this case, how many layers does the shape have? It will always entail that there is only one value on the output. Now, I don't know if you realize what we are doing here, but we are actually expanding the number base we are working in. We are creating a space for ourselves in which we are no longer confined by the Boolean 1 or 0. A Boolean 1 or 0 system is binary, and it can help answer any yes or no question. 1 means the answer is yes, 0 means the answer is no. So here, we are actually expanding the framework we are working in a way that allows us to break away from the restriction of only being able to answer yes or no questions in favor of questions that start with how many. In this case, how many layers does the shape have? And the symbols we choose, they represent the answer. We could get by if we had in-game signals for numbers higher than 1, but we don't have those at our disposal, so we resort to choosing symbols that, at least in our minds, represent those values. And as I said, in my mind, I have chosen that a circle represents 1, a rectangle represents 2, and so on. So now that we have encoded our values, we can create a decoder. This last part is very easy in comparison, because now all you have to do is create a set of comparing units to which you connect the exact same set of values you've chosen. And in our case, that will determine which route the signal is passed on to, like so. In this case, we have a shape with 4 layers on it, and therefore the 4th route will be chosen because the signal matches this comparing unit right here. For comparison, if we take a shape with, let's say, 2 layers, then this shape will be transformed in a rectangle that will match with this comparing unit right here, and the output signal is this one, or the chosen route is this one. Now, with a bit of creativity, you can do pretty amazing stuff with this. For example, 2 videos ago, I told you that there are 6 sets of floating shape types that my machine, this machine, takes into account. 1 set of quad floats, 2 sets of tri-floats, and 3 sets of duo floats. So 6 sets in total. Now, can you think of a set of 6 values that would be suitable? Since we are working in Shapes Industries, I sure can. Why not take the combined shapeforms that exist? There are 6 of those, so they make an excellent choice. And I do use these codes in the machine. However, at a given point, I did realize that that wasn't enough. I needed even more info to be packed into those codes. I told you that a certain module of my machine needs to know what the base layer of a selected floating piece is. So I emit a signal that represents that. But now I also have another module that needs to know not which layer the first quadrant from the bottom is on, but which layer from the top. In other words, I need to know not only the base layer of the currently selected piece, but also its height. And so I thought to myself, instead of generating 2 parallel sets of coded shapes, isn't there a way to condense that into just 1 set that contains both ranges of values? Okay, so look at this. What if I assigned shape forms to the bottom layer and shape colors to the top layer? So a circle would mean that the currently selected piece has its lowest quadrant on layer 1. A rectangle means that the lowest quadrant is on layer 2, and a star means that the lowest quadrant is located on layer 3. Simultaneously, a red shape means that the highest quadrant is located on the first layer from the top. A green color means that the highest quadrant is located on the second layer from the top, and finally a blue color means that the highest quadrant is located on the third layer counting from the top. And if we combine this, we get a system which unambiguously represents all possible scenarios. Quad floats are represented by a red circle. The base layer is layer 1. The top layer is the first from the top, and therefore the piece height is 4. Tri-floats 1, 2, 3, that's these ones, they are represented by a green circle. The base layer is 1, the top layer is the second layer from the top, and therefore the shape height is 3. Tri-floats 2, 3, 4 are represented by a red square. The base layer is 2, the top layer is the first from the top, and therefore the shape height is 3. Duo floats 1, 2 are represented by a blue circle. The base layer is 1, therefore a circle, and the top layer is the third from the top, therefore a blue color, and we can determine that the shape height is 2. The second set of duo floats is represented by a green square. A square because the base layer is 2, and a green color because the top layer is the second from the top. The shape height is 2. And finally, the last set of duo floats is represented by a red star. The star means that the base layer is layer 3, and the red color means the top layer is the first from the top. Again, we can deduct that the height is 2. And so now, I have one consistent set of values that contains 2 types of information. The module that needs to know what the base layer is, it does not care about the color. It analyzes the shape. It will behave, if it is a circle, it will behave according to scenario 1. If it is a square, scenario 2. If it's a star, scenario 3, regardless of what the shape color is. And the other module will only look at the colors and disregards the shape entirely. If it's red, scenario 1. Green, scenario 2. Blue, scenario 3, regardless of what the shape form is. So you see that with this technique, it's possible to have only one value on a single wire that can tell 2 entirely different modules, 2 entire modules, what they need to do. And all we need to do is put an analyzer unit at the end that reads either one side of the information or the other. And this is just the beginning. The BEASTMAM is chock full of this type of shape coding mechanisms. Once you get the hang of this, you will open up a whole new world of possibilities for connecting various modules in your machine with one another in an extremely efficient manner, paving the way for the creation of intricate setups where you make your different modules work with each other, creating dependencies between them, and having each one pass on their own unique set of instructions to the next. Now, over the course of the following videos, we will pass by the entire, I think, dozen or so of coded information sets that I have used in this machine. So if you're interested to see how it works in practice, then definitely be sure to subscribe to the channel and hit the notification bell so you are alerted when the new videos get published. And with that said, I believe we can wrap it up for today. I want to thank you very much for watching. I hope your mind has been blown. And if you liked the video, please do leave a thumbs up or a nice comment. That's always kindly appreciated. For now, have a great day. I am signing off. Take care, everybody. Bye-bye.